Welcome back to our lesson practice review. We are on our second chapter and second lesson where we are going to be reviewing quadratics a little bit more. For our summary of what happened in lesson 2, we're really focused on the quadratic equations and which form gives us which key features. There's 3 different forms we talked about in lesson 1. Now we're going to need to be able to be given one form and then kind of create the other ones. So the challenging one that we've worked on this lesson is when we're given standard form, which standard form is very helpful. Let's say this example given to give us the y-intercept, because it's always just kind of our, what we call our c value here, constant value. And so the hard part is now that we need to put it in factored form to find our x-intercepts. Well, we got to now factor this equation here. And oftentimes the best way to do this is using our box method, where we are putting the first term here in our first box, our last term here in our last box, and then we have to find a way to split up negative 5x into 2 different spots. And so this may be an old man method, but if we were to multiply, these two together, 2x squared times negative 12, and then we put that term that we're trying to split up in the bottom here, and we're looking for the 2 terms that multiply to the top and add to the bottom. So if I were to do that, 8 and 3 multiply to 24, and then I need to make the 8 negative because it makes the top negative, and then when I add negative 8 plus 3x, it gives us negative 5x. So that tells us what goes in these 2 spots here. And then I can just figure out what goes on the outside that multiplies to what goes on the inside here, which would end up being 3 and negative 4, which then tells us our factored form here. So 2x plus 3, and then x minus 4 from here. And then to find the x-intercepts, we just set those things equal to 0. So let's go ahead and get some of our practice in here. For problems number 1 and 2, we're going to use the quadratic function y equals 2x plus 1 times x minus 3 to identify each of the key features. Number 1 asks us for the x-intercepts. The factored form gives us our x-intercepts by just setting each of these pieces here equal to 0. And we end up getting, and we divide by 2, negative 1/2. That's our first x-intercept. I'll write it up here. And then our second x-intercept is given to us by this piece, x minus 3 equals 0. Add 3 to both sides, and 3 comma 0. So there's our x-intercepts for number 1. Number 2 asks us to find the y-intercept. Now, the y-intercept, it's easier to find in standard form, so I'm going to actually take this original function here, and I'm actually going to multiply it out to put it in standard form. So to do that, I'm going to put those terms on the outside, 2x plus 1 and x minus 3. 2x times x is 2x squared, x times 1, 2x times negative 3, and then 1 times negative 3. And now I'm going to combine like terms and add all this stuff on the inside together, which gives me my standard form of 2x squared minus 5x, because I added these together, minus 3. And so with that, when I try to find the y-intercept, that's when I plug in 0 for x. This becomes 0, this becomes 0. I'm left with my y-intercept of 0 comma negative 3. Sorry, my y-intercept. Number 3, which equation is equivalent to this equation here, which is in standard form? So to do that, to check that actually, I could do one of 2 ways. One, I could go through and I could actually multiply out each of these here. But the faster way, the better way, the way that I really want us to be able to do this is to be able to factor this, go from standard form into factored form. So in my box here, I'm putting the first term in the top left, my last term in the bottom right, and this middle term, negative 3x. I need to figure out what goes, or how I break that up into 2 pieces. The way I'm going to do that is multiply 2x squared and negative 2 to get negative 4x squared. And I need to find 2 numbers that multiply to negative 4x squared that add to negative 3x squared, which would be negative 4x and positive x. And again, this is kind of like the actual mathy part. It takes a little bit of practice to get used to find those values, but then those go inside of our box here. And then we go ahead and try and figure out what has to go on the outside to multiply in what's in the box here. And so 2x and x gets us this first box, and then x times 1 is x, and then 1 times -2 is -2, and then just double checking 2x times -2x is -4x. And so I know that this actually becomes y equals 2x plus 1 from the top here times x minus 2, which is D for our answer for number 3. Problems 4 and 5, rewrite each equation in factored form. So I'm going to go ahead and do that same process where I'm going to be factoring them with our box method. I'm going to go through and first term, first box, last term, last box. What multiplies to 10x squared, that adds to 7x, which would be 5x and 2x. And then what goes on the outside, I always like to do this first two here first because it's usually pretty straightforward. 2x and x squared. The 2x has to be here because, because we see this 2x on the top right. So 2x and 1 gives us this number, and then 5 completes this here. So this is the real, like, again, practice here, this diamond and box to help us factor it. The more we get practice with that, the easier it'll come naturally. So this becomes 2x plus 5 and x plus 1. If you did x plus 1 and 2x plus 5 switched, that wouldn't change it. That's still the correct answer. Next one for number 5 here, same idea. My box down here, we got first term. I'm getting a little messy here, sorry. Last term, and then I'm breaking up 5x, whatever multiplies to -6x squared. And again, I'm getting that by multiplying these two terms, which would be just 6x and -x. So that's what goes inside the box here. I know the 3x has to go on the top and the x has to go here, again, because I'm just looking at these corner spots to figure out what would end up multiplying into there. So 3x times 2 and x times -1, and then 2 times -1 is -2. So we end up getting 3x minus 1 times x plus 2, which is our factored form. Next up, number 6, write an equation in standard form that has the x-intercepts of 3 and -5. So if I were to write it in standard form, since I know that my intercepts are at 3 and -5, that means that I'm kind of working backwards here to get my factors of factored form. And so I can kind of take this and write out my factored form of x minus 3 and x plus 5. And now to put it in standard form, I'm just going to multiply these two terms together. So in my box, x plus 5, x minus 3, x times x is x squared, 5 times x, -3 times x, and -15. I combine like terms to get my final equation here, which y equals x squared. Combine like terms to get plus 2x minus 15. Number 7, write an equation in factor form that has a y-intercept of -6. And so to do this, I need to know a couple of things about our quadratics here. The first thing is that if I have a y-intercept of -6, if we look back at the last one, the y-intercept is always told to us by this last term. This last term, if I was looking for, factored form, I'm looking for what these, two numbers on the end multiply to. That gives us kind of our y-intercept. So if our y-intercept is at -6, I'm looking for two things that multiply to -6. So again, maybe I'm going through this too fast, but if I was to do a +3 and a -2, when I multiply these two things out, x and 3, x and -2, again, all this stuff on the inside doesn't really change what I'm really looking for. which is just this part right here, because this part right here is what tells me the y-intercept. So kind of reverting back to the equation that we got, this one here would be in factored form and has a y-intercept of -6. Number 8, write an equation in factored form that has x-intercepts that are not integers. Okay, this one here, pretty straightforward. I mean, like you've seen a couple different things in lessons and stuff like that. Let's give you two different types of answers here. One, you could just say like, oh, x minus, 2.34. Those are not integers. But really, what you're going to see more often probably is not dealing with decimals in these, and more so dealing with fractions. And so one of the situations that we've seen in the practice earlier, which would maybe be a possible answer here, is if we scroll back up to D here. This here, if I have 2x plus 1, that's going to end up giving us a fractional answer. Again, looking at number 1 here, we have this x-intercept that is -1/2. So again, using that idea, if we're going to see things that have something like 3x plus 2 or 2x plus 1, these are factored form, yes, and we have whole numbers in our factored form. But if I go to try and find the x-intercepts, then I go and I do, 3x plus 2 equals 0. I subtract 2 from both sides, divide by 3, and I get this fractional x-intercept. And so more often what we are going to see is answers that looks like this, factored forms that have fractional answers when, this x here has something in front of it. For number 9, write 3 equations in factored form that are equivalent to 2x squared plus 14x plus 12. Okay, I'm going to do this in a couple of different ways to kind of show you why this makes sense. When I am looking to factor something that's in standard form here, I usually look for a greatest common factor first. For example, this one here has a 2 in every one of these terms here. So if I factored that out, technically this would be equivalent to x squared plus 7x plus 6. And so now if I factored this part here using my diamond and box here, I got x squared, I got 6. Something that multiplies to 6x squared that adds to 7x would just be 6x and x, which would mean that I'm going through this a little bit quicker just because I'm hoping that factoring is coming back to you here. And I end up, when I factor it, getting x plus 6 and x plus 1. So I end up getting, actually, let's go this way. End up getting y equals 2, because that 2 is still in the front, and then x plus 6, and then x plus 1. And so that's the first way that I could factor this, is by using the greatest common factor first. If I were to not do that, it would look a little bit different, and our answer would look a little different. It would still be correct, just not all the way factored here, if we just took this straight in, threw it into the box here. So first term, first box, last term, last box, 14x, I'm going to try and figure out what multiplies to 24x squared that adds to 14, which would just be 12x and 2x. 12x, 2x. And so once I've gotten to this point, so here's where kind of these other two answers come from, is that if we have, let's say I put the 2x here and the x here, then this now has to be 6. This here has to be 2. And so I get 2x plus 2 and x plus 6. Whereas, let's say I took the exact same box. I'm just going to repeat this box here. Same box, 2x squared, 12x, 2x, 12. But I put this 2x over here. Then this here has to be 12. This has to be 1. And I get instead this, what is this, 2x plus 12 and x plus 1, which also works. The last thing I'm going to show you here is just the reason that all three of these are the same is if I did this box first and then did the greatest common factor afterwards, for example, right here, I see the greatest common factor would be 2. I'd pull the 2 out here, which would make this x and this 1, and now it matches this one up here. Greatest common factor here would be 2 also, which would make this just x plus 6, and x plus 1, which would be the same as what we started with up here. And so really like all of these three answers here are all equivalent. We're just look a little bit different in this depending on how you factored it. And again, like personally, I think this is the best answer because it's the most factored. It's also, I think, easiest to do the greatest common factor first, but it's a good example to show all of them. On to our spiral review. The first thing we're asked to do is to multiply these two together. I'm going to use my trusty box here, 2x minus 3, 2x plus 3. What we notice is that these are the same numbers. It's just one of them is subtraction and one of them is addition. This is probably not part of the lesson, but conjugates, that's what these are called, conjugates, when we multiply these, or when we have these two binomials that are adding and subtracting but the same things. It's an important term that you eventually need in the later maths, but we may or may not use it as we go forward here. When I multiply these out, what is special about conjugates is that you see that these corner boxes here end up becoming opposites of each other. So when we combine like terms, they go away and they leave us with what we call a difference of squares. And when I factor x squared minus 16, same idea, there's just backwards here, that this is technically a difference of squares. And so when I'm factoring a difference of squares, it's really just, you'll notice the, square root of the first term and the square root of the second term. And then we put that in here and we add and we subtract. And so what you can kind of see here is that difference of squares, when we factor them, become conjugates. If we take conjugates and we multiply them together, they become difference of squares. That wraps up our chapter 2, lesson 2 practice. We're going to be starting lesson number 3 here pretty soon if you stick with us and continue talking about quadratics.